Today in India, Earth observation satellites play a vital role in the overall development of the country. The inputs gathered from them aid in a variety of tasks like weather monitoring, urban and rural planning, agriculture, forestry, watershed development, natural resource mapping, coastal zone mapping, oceanography, cartography, and many more. Our country has a number of state-of-the-art Earth observation satellites which are dedicated for various thematic applications and generally operate from low Earth orbits. Due to this, they cover a relative smaller region at a time and have to scan the Earth step by step in every revolution around the Earth and revisit the same area only after a few days depending on their orbits. However, many applications like meteorology and disaster management require imaging large areas of Earth and atmosphere very frequently. For this, the satellite has to be placed in a geostationary orbit, which is at an altitude of nearly 36,000 kilometers over the equator. Though ISRO has been performing the task of Earth imaging from geostationary orbit since the past 3 decades, GISAT-1 is the latest Earth observation satellite developed by ISRO that will be placed in a geostationary orbit. From its orbital location, GISAT-1 will continuously observe land, ocean, and atmospheric parameters at relatively higher resolution, ranging from 50 to 320 meters using appropriate spectral bands for different applications. Weighing nearly 2,275 kilograms, GISAT-1 will be launched by the GSLV F10, which is the 14th flight of GSLV Mark II vehicle. The rocket will take off from the second launch pad of the Indian spaceport at Satish Dhawan Space Centre, Shar, Sriharikota. After reaching geosynchronous transfer orbit, GISAT-1 will be commanded from ground to reach its geostationary orbital slot by using its own propulsion system. GSLV Mark II comprises 3 stages. The first stage consists of a rocket motor with 138 tons of solid propellant and 4 strap-on boosters, each carrying 42 tons of Earth-storable liquid propellants. The second stage also uses Earth-storable liquid propellants, while the indigenous cryogenic upper stage forms the third stage. The satellite will be placed in the geostationary orbit over the Indian subcontinent at 85.5 degree east longitude. It will generate 2-dimensional imagery by slewing in west-east direction and stepping in north-south direction. The scan mode includes coverage of entire Indian subcontinent landmass and oceans. It has multispectral, multi-resolution imaging instrument which is capable of imaging full or part of the Earth disk with high-resolution multispectral visible near-infrared, hyperspectral visible near-infrared, and hyperspectral shortwave infrared. The mission life of the satellite will be around 7 years. Imagery from GISAT-1 will be utilized for a host of applications including crop monitoring at regional and national level, drought progression and assessment, ocean and coastal zone management, fog detection and warning, disaster management, dust monitoring, and many more. Indian Earth observation satellites are an excellent example of the country's technological strength in harnessing the space technology for the development of the country. The addition of GISAT-1 to this group will greatly enhance our capability to observe and understand the Earth and its atmosphere.